In one of the most intriguing astronomical discoveries of the century, scientists revealed evidence of a small world that defied expectations, a world quietly shining in the darkness of space. The announcement came from NASA, an agency long known for expanding the boundaries of human knowledge. But this time, the revelation didn't involve a distant galaxy or a newly discovered exoplanet. It came from a familiar region, the asteroid belt between Mars and Jupiter, where a modest, overlooked world had begun to emit a mysterious glow. At first glance, Ceres appeared ordinary, a rocky, cratered object adrift among countless fragments of stone and dust. But new images told another story. Across its scarred surface were bright patches of light, shining like scattered beacons in the void. The discovery ignited curiosity across the globe. Were these glimmers the reflection of ice? Deposits of salt? Or could they point to something we had never seen before, a form of planetary activity entirely unique within our solar system? A handful of daring minds even whispered a question that bordered on science fiction. Could the lights be artificial? Most experts dismissed the idea, yet few could deny that something unusual was happening on this tiny world. A forgotten planet reborn Ceres, the first object ever discovered in the asteroid belt, has a long and curious history. In 1801, the Italian astronomer Giuseppe Piazzi spotted it through his telescope and believed he had found a new planet. But soon, other small worlds were discovered in the same region, and Ceres was reclassified as just another asteroid. For more than a century, it faded into scientific obscurity. Then, in 2006, the same year Pluto was redefined, Ceres was promoted once again, this time to dwarf planet status, becoming the only one of its kind in the inner solar system. It had regained its title as a world in its own right. To truly understand it, NASA launched a spacecraft called Dawn in 2007. Equipped with cutting-edge ion propulsion, Dawn was the first mission ever designed to orbit two separate celestial bodies, Vesta and Ceres. Its engines glowed with an otherworldly blue light, gently pushing it across millions of kilometers of interplanetary space. Dawn first visited Vesta, studying its rugged terrain and ancient scars, remnants of the violent collisions that shaped the early solar system. Then, in 2015, it reached its final destination, Ceres. What it found would change everything. The lights of Ceres as dawn approached, its cameras captured scenes unlike any ever seen before. Inside a massive crater nearly 90 kilometers wide, brilliant white spots gleamed from the shadows. They reflected sunlight so strongly that, for a moment, scientists thought the images were flawed. But the data was real. These glowing regions became known as faculae. They weren't isolated points, they were networks of reflective material spread across the crater's floor and ridges. After months of analysis, scientists confirmed that these lights were deposits of sodium carbonate, a type of salt left behind when salty liquid, or brine, rose from underground and evaporated into space. This process, called cryovolcanism, is a form of icy volcanism. Instead of molten rock and lava, the eruptions release water, ammonia, and other volatiles that freeze or sublimate immediately after reaching the surface. What remains are gleaming crusts of salt, the shining mirrors that first caught Earth's attention. But perhaps the most remarkable finding was this: Ceres might still be geologically active. Hazy mists and transient clouds appeared inside certain craters, hinting that water vapor may still escape from beneath the crust even today. This suggested that Ceres is not a dead, frozen relic, but a living world, quietly reshaping itself in the dark. A hidden ocean beneath the crust. The deeper scientists looked, the more complex Ceres became. Beneath its surface lies a mixture of rock, ice, and briny water, forming a layered structure similar to larger worlds like Europa and Enceladus. Its crust is porous and fragile, while below it may rest a mantle rich in frozen brines and hydrated minerals. The heat that keeps portions of this liquid stable likely comes from radioactive decay within Ceres' core, a slow but steady warmth that has endured for billions of years. Over immense spans of time, that heat may have allowed liquid water to circulate, carrying salts and minerals to the surface through cracks and fissures. The mystery beneath Ceres. In the cold silence between Mars and Jupiter lies a world that defies expectations: Ceres, the largest object in the asteroid belt. For centuries, it appeared as nothing more than a faint point of light through Earth's telescopes, a remnant from the dawn of the solar system. But when NASA's Dawn spacecraft arrived in 2015, that illusion shattered. Ceres wasn't a barren rock. It was alive, not biologically, perhaps, but geologically, chemically, and in its quiet way, profoundly mysterious. The spacecraft's cameras revealed something startling: bright, shimmering patches scattered across ancient craters. These luminous spots reflected sunlight like mirrors, drawing comparisons to ice, salt, and even artificial lights. Among them, the Achater crater stood out, a basin nearly 90 kilometers wide, glowing with strange white material at its center. For a moment, the scientific community, and the world, paused. Were these lights a geological process, or something far more unusual? Soon, the Dawn mission's instruments delivered the first clues. They identified the bright material as sodium carbonate, a type of salt that forms when briny water evaporates. In other words, the lights were the frozen remnants of underground liquid that once seeped to the surface, evaporated, and left crystalline deposits behind. This discovery changed everything. Ceres wasn't just a lifeless rock. It was a chemically active world with a history of liquid water, internal heat, and movement beneath its crust. A world that shouldn't be alive, but the story deepened. Adding to the mystery, Dawn's instruments detected traces of ammonia-bearing clays, compounds rarely seen in the inner solar system. This suggested something extraordinary. Ceres might not have formed where it is today. It could have originated much farther from the Sun, near the icy realms of Jupiter and Saturn, before drifting inward to its current home. Ammonia, scientists realized, is no ordinary ingredient. It acts like antifreeze, lowering water's freezing point and allowing liquid brine to exist even in the frigid darkness of deep space. That chemistry means one astonishing thing. Beneath its frozen crust, Ceres may once have harbored subsurface oceans, pockets of salty water warm enough to allow the chemistry of life to take its first steps. Could those ancient oceans have sheltered primitive microbial life? And if so, might traces of it still linger, entombed beneath kilometers of ice and salt, preserved for billions of years? The questions remain unanswered, but they continue to haunt every scientist who studies this enigmatic world. A window to the early solar system. Even if life never existed there, Ceres remains an irreplaceable window into the early solar system. It is one of the most ancient and least altered bodies orbiting the Sun, a kind of time capsule holding secrets from when planets were first being born. Its crust bears the scars of countless impacts, but also the smooth flows of ancient ice and frozen mud, proof that this world has not been entirely still. Among its most striking features stands Ahuna Mons, a solitary dome towering nearly 4 kilometers high. Unlike volcanoes on Earth, it isn't made of molten rock. It's made of frozen, salty mud, pushed up by internal heat, erupting slowly over millennia through cracks in the surface, and solidifying into an icy mountain. This cryovolcano stands as silent testimony that even in the smallest of worlds, internal forces can endure for billions of years. The more scientists learned, the clearer the message became. Small worlds are not dead worlds. Even far from the Sun's warmth, hidden energy and chemistry can shape landscapes, and perhaps, spark the faint flicker of life. The legacy of Dawn. When NASA's Dawn mission finally ended in 2018, The spacecraft entered a quiet orbit around Ceres, a permanent sentinel circling the world it revealed. Though its signal has gone silent, the data it gathered continues to transform our understanding of planetary evolution. It proved that water and salt are not rare anomalies, but fundamental ingredients woven into the story of our solar system. It showed that the potential for habitability extends far beyond Earth, that even the humblest bodies between the planets can carry echoes of the same processes that made us possible. The bright lights that once seemed mysterious, even otherworldly, are now understood as symbols of persistence, a reminder that water, energy, and chemistry still dance beneath Ceres' frozen skin. Each crater, each glimmering patch of salt, tells a story of renewal, of warmth struggling to endure in the cold dark. A quiet revelation, Ceres, once overlooked as just another asteroid, has become something greater, a living archive of creation. A world that whispers of oceans long vanished, of ancient heat still flickering deep within, and of a universe where life's potential may lie hidden in the most unexpected places. In the faint glimmer of its white scars, we find not just the reflection of sunlight, but of ourselves. Our curiosity. Our search for meaning. Our endless desire to understand the worlds around us. The Dawn spacecraft rests silently now, orbiting forever in the shadows of that lonely world. But its discoveries continue to echo, across labs, across classrooms, across the imaginations of all who look up and wonder. Ceres reminds us that exploration doesn't always lead outward. Sometimes, the greatest discoveries lie in the quiet corners, in the subtle glow of salt and ice, in the forgotten worlds that still hold the stories of